What's up, ninth period? You guys should have 3 minutes to work on the bell ringer. You should have your bell ringers out and you should be working on this. You're going to need a calculator and a periodic table, so you might as well go ahead and take those out now. You can definitely use the Mola roadmap on the wall, so you guys have 3 minutes starting now. You guys have about 1 minute left. Okay, before we get into too much detail about how to solve this problem mathematically, I want to talk about the concept behind representative particles. These are called atoms, obviously, it says it in the question, but I want to make sure that you guys understand the 3 separate types of representative particles. So a representative particle is the smallest piece of a particle of something that still maintains the property of that particle. So for example, something like sodium chloride has the properties of salt, but if you break apart the sodium and the chlorine, they have 2 totally separate properties. So the smallest unit of a sodium chloride particle you can have is called a formula unit, because that still has the properties of salt. If you broke it apart further, it would be sodium and be chlorine, it would be different. Okay? So there's 3 types of 3 types of representative particles. For atoms, they're used when you have a single element by itself. Okay? Only for that situation. For molecules, they're used when you have a molecular compound, a diatomic, or a acid. The other type is called a formula unit, or FUN for short, and those are used for ionic compounds. I want you to write this down on your bell ringer right now. 20 more seconds. All right, so now that we have that written down, you have that on your notes, you can reference that when you need to. So these are called atoms because obviously sulfur is by itself. All right, so now we have to talk about the actual math behind this. So we're starting with 6.7 times 10 to the 25 atoms of sulfur. We're going to multiply by a fraction. We want to get rid of atoms, so we're going to put atoms on the bottom and moles on the top. You have 1 mole because and moles always get to 1 when it's over something like atoms. There are 6.02 times 10 to the 23rd atoms in 1 mole of something. And again, you put moles on the bottom, grams on the top, and in 1 mole you have 32.06 grams of sulfur. When we multiply across, you should get something like 3,580 grams of sulfur. And with the proper number of significant figures, since we have 2 significant figures, that should be 3,600 grams of sulfur. Okay, so I know that was kind of fast, but this is review. To be fair, we've done stuff like this before. Today we're working on simple mass or simple molar calculations. So these are just going to be only one type of substance. There's no mole-to-mole ratios today, just one simple type. Okay, now that we have the amount of sulfur that we should have, we're going to transition to getting ready for class. Take out a separate sheet of paper. If you don't have a separate sheet of paper, I left some separate sheets of paper next to the door, so you can go get a separate sheet of paper there. You also need a bell ringer, or sorry, a calculator and a periodic table. Okay, now we're going to get started on the review. The instructions for the review are pretty simple. On a separate sheet of paper with a partner, you can work together. You're going to make sure that for any problem that you solve, you're showing all units. You round your answers to the correct number of significant figures, and that you're showing your work along the way. Showing your work during molar calculations is important because it really shows how long it takes to, it really shows the way on like your mistakes or any errors that you're making, or like if you should be canceling out units to check your answers. Behind Alondra, there are 6 types of problems. They're color-coded. The orange is for molar mass. The blue is for single-step mole conversions. The yellow is for multi-step. That's the kind that we just did as the bell ringer. Purple is for total mass, pink is for total mass, green is for mass percent, and purple is for empirical molecular formulas. If you feel like you don't need to do any of this stuff, like you feel like you've already learned it all, or you remember it all from when we did it in the fall, I have an extension activity that I left next to it. It's labeled extension activity, so you can grab that and work on that. It's something that you were going to learn in AP Chemistry. Besides that, you should go grab a different color of paper. Start with the orange and the blue. If you're not sure, if you struggled with the bell ringer, if you want to start a little slower. And then if you're looking for just like a variety of problems, you can of course take a multiple of colors. When you finish at the end of class, please make sure you put the slips of paper back where you found them in the neatly color-coded area. I reuse these from year to year and I don't want to lose them, so please take good care of them. Besides that, you guys should use the rest of the class period to review simple molar calculations. Miss Lewis is in there, so please be very respectful of her and her time. If you would like to buy an iPod Pass, she can sell you one during this time. There are answer keys on your table that have the work shown for you. So not only do you have an answer key, but you have a guide to how to solve a problem. You should have about 30 minutes left, 30-40 minutes. You should complete about 2 problems every 10 minutes. So you should have 6 to 7 to 8 problems done during this time. No homework, and that's about it. Thank you guys for paying attention, and good luck practicing molar calculations. This will serve you well in the future.